All right, Chapter 2, Section 3, Conditional and Biconditional Statements. This was my favorite part of logic. I even took an entire college class called logic and just doing this stuff all of the time. It was my favorite thing to do. We're going to be able to write and determine the truth value of conditional and biconditional statements. Bi meaning two. So it's just going to have two conditionals in it at the same time. A conditional statement is a statement that can be written in if-then form. The symbolic form is P, then Q. If P, then Q, or P implies Q. The hypothesis is the phrase immediately following the word if. We have probably heard the word hypothesis before. You might have heard it in science class. You might have heard it in like stories about Sherlock Holmes and other detectives and things. They're all different versions of the word hypothesis. Science is a concept that you think is correct, but you haven't proven to be true. In the Sherlock Holmes situation is like a guess or an idea. And actually, he even in the Sherlock Holmes is actually meaning this. It's like the beginning part of a conditional. He's got an idea of what's going to follow after the fact. But usually people kind of mean guess, and that's not what this is. This is just the statement that comes after if. And it doesn't matter where the if is, because sometimes you can write the sentences backwards. You can put the then first and the if last, but the conditional part of it is always if and then. Then always follows. Then is for after. Okay. The conclusion is the phrase immediately following the word then, or is the part that doesn't have the if in front of it. Okay. So if you live in Nashville, then you live in Tennessee. Well, the hypothesis part is you live in Nashville. And the conclusion, the part after the then, is you live in Tennessee. That's not the right letter. There's a lot of double letters in Tennessee. Never really noticed that. If the sum of the measures of two angles is 90 degrees, so sum of the measures of two angles is 90 degrees, then they are complementary. If a quadrilateral is a square, so too close. Quadrilateral or four-sided is a square, then it has four right angles. That's it. Hypothesis conclusion. If, then. Now, what I want to show you about that other if, then, it's always the if part that follows. I could rewrite number one, for instance, as you live in Tennessee if you live in Nashville. Notice that this part's still the if, so this part is still the hypothesis because it follows the end. There's an understood then up here. Okay? So sometimes the sentences are written in reverse order, but the P and the Q are still the things that follow the if and follow the then. The hypothesis is always first. The conclusion is always second. Okay? So let's look. Writing conditional statements, write the following statements as an if-then form. This part gets a little tricky because you got to turn something that doesn't have an if-then statement into something that does have an if-then statement. So Let's see. An obtuse angle has a measure greater than 90. You're going to end up repeating parts of these things into themselves, right? So we could say this is all about an angle and then its measure. Like we're going to really kind of break it here about the has, about the verb. Okay, so and if an angle, that's what we're talking, is obtuse. So if an angle is obtuse, then it has a measure greater than 90 degrees. Okay. All numbers divisible by 4 are also divisible by 2. Okay. All numbers divisible by 4. So if a number, talking about numbers, is divisible by 4, then it is divisible by 2. Notice we cut a few of the words out and rewrote it from here to there. Like we didn't put the word also, and we didn't put the word all. But if it's a number and divisible by 4, then it is also divisible by 2. Then it is divisible by 2. Okay. Number 6, states on the East Coast border the Atlantic Ocean. So we're talking about states, and border is the verb right here. This was are. There's the has there. Okay, so states on the East Coast border the Atlantic Ocean. So if a state is on the East Coast, then it borders, is a better way to say that. Then it borders the Atlantic Ocean. Valentine's Day is in February. If it is Valentine's Day, then it is February. I have to say it weird, the way that it's spelled, to know how to spell it, because it's a weird old freaking sentence or word. Don't like it. Okay? But that's how it goes. Prime numbers have 2 factors, 1 and itself. So prime numbers, what we're talking about, have. So if a number is a prime number, then it has 2 factors, 1 and itself. And that's how it goes. Now, when we talk about conditional statements, and we're still talking about conditionals. Conditionals is the first version, P then Q. So I'm going to put that on here, P then Q. There are other forms based on what order we put the P in the Q from the original conditional statement. Something called the inverse, and I like to think of it as the inverse, and that helps me think of not. The inverse is the not one. It is formed by negating the hypothesis and the conclusion, right? We talked about negating. So its symbolization is not P, then not Q. The converse, and I like to think of con there, is formed by switching the hypothesis and the conclusion. So we do if Q, then P. Okay. And the reason I think of converse is I kind of think of a con artist, and a con artist is going to switch things around on you and lie to get you to do what they want you to do. Okay. That's what a con man does. And then the last one is a contrapositive. And they both have con, but contrapositive is a way longer word. It's got a lot more stuff in it. Contra means like the other side, positive. Like the other side of positive is negative, and there's a whole bunch of stuff. So it's actually doing both inversing and conversing. So it is formed by negating and switching the hypothesis and the conclusion. So it's going to be not Q, then not P. Okay. So the conditional is P then Q, the original statement. If this, then that. Inversing is notting them. So not P, then not Q. Conversing is switching Q, then P. If Q, then P. And the contrapositive is switching and notting. So not Q, then not P. Now, we're going to try this out. Write the inverse, converse, and contrapositive of the following conditional statements. Determine the truth value. If false, tell me why you think it's false. So here's the the conditional statement. If it is Saturday, then there is no school. Inverse means to not that. So the inverse, and I'm going to write it out here, is just going to be not P, then not Q. Just so I remember not. So if it is not Saturday, then, remember not P, not Q, then there is school. Or there is not school. Not becomes negative becomes positive, so there is school. Now, do we think that's true? If it is not Saturday, then there is school. Well, I say that's false. Because I know about this little thing called Sunday. Okay. Sunday is a day of the week that is not Saturday, but there is not school. So that is not a true statement. Just because it's not Saturday doesn't mean you have to go to school. Don't forget about Sunday. The converse. If there is no school, then, that's a them, then it is Saturday. Oh, why is it getting weird? I don't think that's true either, because maybe it's a holiday. Or if you wanted to, you could say, use the same excuse. Sunday tells me that, it doesn't have to be Saturday just because there's no school. Maybe it's because it's Sunday. Maybe it's because it's Thanksgiving. Maybe it's because it's fall break. Maybe it's because it's spring break. Okay, or any of the other days that you don't have to go to school. Now, the contrapositive, switch them and not them. So if we look at the inverse, we just then flip those. So if there is school, then it is not Saturday. Now let's see, if there is school, it's not going to be on a Saturday, so it's definitely not a Saturday. So I'm going to go with, that's true. If you're having school, it ain't Saturday. And we're not going to count the getting in trouble and having to do Saturday school business. Nope. If it's school, it ain't Saturday or Sunday or a holiday. All right, let's try this one. If the product of two numbers is odd, then both numbers must be odd. Okay, so the inverse is we're going to flip those. Remember, it's P. Oh, yeah, I guess we could do those up here, right? We did Q, then P, and then we did not Q, then not P. That's how those go, okay? Not them, switch them, not and switch them. So this is P, not P, then not Q. So if The product of two numbers is, now we have to, let's see, if the product of two numbers is not odd, okay, or we could call it, what's the thing of not odd? If it's not odd, then it's even. So if the product of two numbers is even, right, the opposite of odd, then both numbers must be even as well. Well, let's see. Is there any set of numbers that you can think of that you multiply them together, you get an even number, and they're not both even numbers? Well, let's see. How about, I mean, you could go really easy, right? I think that's false. Because 1 times 2 equals 2. The result is an even, but not both of them are even. Or any other set of an odd and an even number multiplied together becomes an even number. Okay, most likely. 4 and 7, 2 and 9, and a bunch of others. So pick your favorite. It's false. Now let's do the converse. Let's do Q, then P. Okay, so let's flip them back. If two numbers are odd, it's weird to say both, so we're just going to say two numbers. If the two numbers are odd, then both, here's where we'll put the both. Oh, where should we do it like this? Then the product of both is odd. Let's see. If two numbers are odd, then the product of both numbers is odd. Well, 1 and 3 is 3. 1 in any odd number is an odd number. Let's see. 3 and 5 is 15. 3 and 3 is 9. 3 and 7 is 21. I can't really think of anything that would work. Most of them all end up as odd. And it makes sense because if you do it in even number times, it's going to even itself out. The 1s at the end or the 3s at the end become 6s or 1s or whatever, or 2s. You double it, and that's no problem, as long as you're multiplying by something that has a 2 in it. But if you're multiplying by something that has an extra thing, a non-even number of stuff, it's going to end up as odd. So yeah, that's true. Now the contrapositive, not Q, then not P. So we're going to take that inverse, but we're going to flip it back and forth. If two numbers, that says numbers, sorry. If two numbers are even, okay, if two numbers are even, do have to make it make sentence sense, then the product of both, is even. So let's see. If two numbers are even, then their product is even. Well, if an odd and an even makes an even, and even and an even only makes it even as well, that's actually true. You can't multiply something with a factor of 2 in it times anything and it still become an odd thing because you double it. And double is always going to get rid of your odd. Okay. All right, go ahead and give it a pause. Try number 3 and then come back and see how you did. Okay, here we go. Inverse is P then Q. And we're going to not P and then not Q. I'm always used to the conditional first. This P, that Q. There we go. So so we're gonna not them. So if the temperature is not 25 degrees Fahrenheit, if the temp is not 25 degrees Fahrenheit, then it is not below freezing. And that would be false, because freezing is actually at 32 degrees Fahrenheit, so it could be 31 or 32, or no, it could be 31 or 30 or 29 or 27 or 28 or 20. It could be any of those. It could be 20 degrees, right? We could say it's 20, or we could say it's 31. It could be anything as long as it's below 32. So not being 25 doesn't make that correct. Now, a converse, Q then P. So we're going to flip the sentence, okay? If it is below freezing, then it is 25 degrees Fahrenheit. Well, no, because below freezing is anywhere below 32, so that's false. Same reason, it could be 20 degrees, it could be 31, it could be 30, it could be 28, it could be 5, it could be negative 15. All of that's below freezing. Now let's look at the contrapositive. We're going to take the Q and P, we're going to flip them, and we're going to negate them. So if it is not below freezing, then it is not 25 degrees Fahrenheit. That is actually true. Because if it ain't below freezing, you can't have a number below freezing. Freezing's at 32. So our not Q, the not P, is actually true. Now, let's talk about biconditional statements. A biconditional statement, bi means two, is just that. It's got two conditional statement to it, but it's particular. It is the conjunction, okay, with and of a conditional and its converse. And the converse is the switcherooski, right? So in symbolic form, it is P then Q and Q then P. So we write that as like this, P and then Q. And what this stands for is if and only if. You can actually write the if with a lot of F, okay? Because if and only if can be read as if and only if, okay, with two F's. So a biconditional statement is true when both the conditional and the converse are true, because that's what has to be the case for an and statement. Both sides have to be true. So it has to be true forwards and it has to be true backwards. If it goes forwards and backwards, if this, then that, and if that, then this, and it's both true, it's a biconditional statement that is true. So let's look at some examples here. Given the biconditional statement below, write both the conditional and the converse and determine the truth value of the biconditional. Explain why or why not. Well, the if and only if is the breaking point, and the hypothesis is in front, and the conclusion is in the back. So the conditional would be if two angles are supplementary, then the sum of their measures is 180 degrees, which is true. The converse of that is if the sum of two angles measures is 90 degrees, sorry, 180, hello, 180 degrees, then the two angles are supplementary. Jeez, can't write today. That's true. So the truth value of the whole thing is true. It's true because they're both true. Okay, so if it says explain why, both are true. I wear my snow boots if and only if. There's my if and only if, my if. So I break it up. If I wear my snow boots, then it snows. And the converse is if it snows, then I wear my snow boots. Two words. Now let's think about that. Is the conditional true? If I wear my snow boots, will it then snow? Do my snow boots make snow happen? Are they magic boots that if I put them on, snow happens, and that's why I call them my snow boots? Well, no, that's false. It doesn't snow because I wear my snow boots. Now, if it snows, then I will wear my snow boots is true because I wear those boots for snow. That's why they're called snow boots. So this would be false. The conditional is false. Okay. X squared equals 25 if and only if x equals 5. So if x squared equals 25, then x equals 5. Well, if x squared is 25, and then x equals 5, yeah, maybe. Let's see. If x equals 5, then x squared equals 25. It's much easier to go that way. Because if you take 5 and you square it, 5 times 5 is 25. That one's true. Now, x squared equals 25, then x is 5 is not necessarily true because 5 times 5 is 25, but negative 5 times negative 5 is also 25. So I'm going to say false. The conditional is false. And you'll get in this next year in Algebra 2. You should have done it a little bit last year in Algebra, but you didn't really do a lot of solving of radicals. But whenever you have an x squared equals 25, when you square root to solve, we break that down as 5 times 5 is this, but it could have been both positive or negative. So you always do a plus or minus as your answer because you don't know what the x actually was, but it could have been either, so you actually use both answers. It's either positive 5 or negative 5. It could have been both. Now, I will get 10% off if and only if I spent at least $75. I will get, let's say, if I get 10% off, then I spent at least $75. The converse, if I spent $75, then I get 10% off. Let's see. If I get 10% off, then I spent at least $75. I mean, it could be. But if I spent $75, then I get 10% off. Yeah, I mean, that might make sense if there's a sale going on. But the first one doesn't. You could have got 10% off because you had a coupon. So I'm going to go with false. Ooh, hold on, zoom out. Zoom out. And I'm going to say conditional is false. Mind your P's and Q's. I said it before, and that's where it comes from. Mind your P's and Q's. This is a graphic organizer of logic statements. So this is just another concise piece of notes just to remind you what everything is and where it goes. We're going to use the statements below to write a compound statement. P represents vertical angles are congruent, and Q, 15, is a prime number. A conjunction. That one's and. So it's P and Q. So vertical angles are congruent and 15 is a prime number. They both have to be true, and is a both. And vertical angles are congruent, but 15 is not a prime number because 3 times 5 makes 15, so that's false. Okay. Disjunction, which is or. Either or. So it can be either one to be true. It makes the whole thing true. So that's P or Q. Remember the little guy. You want to be like, I don't know. Okay. It's my little I don't know V guy. So the disjunction, this or that. I don't know, this or that. Okay. Vertical angles are congruent. Or 15 is a prime number. I don't know why I put an E on the end of that. Weird. Now, in a disjunction, you just need one of those to be true. So vertical angles are congruent. Vertical angles are congruent. That's true. And if that piece is true, then the whole thing's true. Because we only need one of the pieces to make that statement a true statement. Because it's an or statement. Now let's look at the conditional sum up. Use the statements below to write the conditional statements below and determine their truth value. P, it's St. Patrick's Day. Q, it is March. The conditional is P, then Q, if it is St. Patrick's Day, then it is March. Yeah, that is true. Can't think of a counterexample. If it's St. Patty's Day, boom, boom, it's March. Now the inverse. Inverse in not. Okay, so I think of in as inverse not. So not P, then not Q. So if it is not St. Patrick's Day, then it's supposed to be an it looks like if it is not March. That'd be false. Because March 1st, 2nd, 3rd, 4th, 5th, 6th, 7th, 8th, 9th, 10th, 11th, 12th, 13th, 14th, 15th, 16th, 18th, 19th, 20th, 21st, 22nd, 23rd, 24th, 25th, 26th, 27th, 28th, 29th, 30th, 31st. Could be any of those other days. And it could be March. Converse. Q, P. Flip it around. If it is March, supposed to capitalize the M there. Excuse me, March. If it is March, then it's St. Patrick's Day. That's also going to be false. Because The same reason we did on the inverse. It could be the 1st, 2nd, 3rd, 4th, 5th, anything but the 17th of March, and then it's not St. Patrick's Day. So that doesn't work. The contrapositive. Not Q, not P. If it is not March, that's a weird ch, then it is not St. Patrick's Day. Let's see. If it's not March, it's not St. Patrick's Day. Well, St. Patrick's Day is in March. If it's not March, then it can't be St. Patrick's Day. So that is a true statement. Now let's look at the biconditional. Biconditional is P and then Q. Notice the arrow has heads on both ends. That means it goes forwards and it goes backwards, just like an equal sign. So it is St. Patrick's Day if and only if it is March. Well, remember, when this is the thing, both the conditional and the converse have to be true. If we look back up here, we said the conditional was, but the converse was not, which means it is not a true biconditional statement. It is not a good if and only if. It is a false one. And that brings us to the end of 2.3 notes. That's your P's and Q's, ladies and gentlemen. Conditional, P then Q. Inverse, not P then not Q. Converse, Q then P. Just switch around like a con artist. Contrapositive, really long word, lots of stuff. Really long word, lots of stuff means do both of the things. Not it and